Hello, 6A. Welcome to Science Day 2 e-learning. So we are continuing on with seasons, describing seasonal changes in the length of the day, how the length of the day is changed in the seasons, and the length of the night changes depending upon the season. And today we're going on to the second part, which is the angle of the sun above the horizon, how that helps describe the seasonal changes. Okay, so first of all, just a couple of things from your seesaw from yesterday. I am going through those. They're great for the most part. But what I've decided to do is I'm going to just check that you have submitted it. And then based upon today's lesson, I want you to go back and confirm that what you have put in your answers you think is truly correct, okay? There's a couple people that I'm noticing things are popping up. I just want you to go back and just double check it before I actually mark it, okay? Also, second thing is there are 2 pages, okay? So just when you click in the document, you need to make sure that you scroll to both of them. Hopefully that is okay for you to do before you press submit. Okay, now getting into today's lesson. Okay, we finished with this yesterday, and this was the second part of what your assignment was, to figure out what is happening in the northern half of the hemisphere in July, what's going on there, why is this happening, and then what's happening in the southern hemisphere in July. Okay, and your answer should kind of relate to like where the hemisphere is pointing. Okay, today, what we are doing is actually you do need to have your science COIL notebook today because we're going to be watching Bill Nye the Science Guy and filling in there's a piece of paper that's like Bill Nye the Science Guy season. So we're going to watch that anyway, which is kind of cool. I'm not going to play the full Bill Nye in this video simply because it takes up so much space when I'm uploading videos, but I'm just going to post the link and then you guys can watch it at your own time after you finish watching this. So the solar arc. Okay, now as we see here, this is us. This would be showing not Abu Dhabi. The path of the sun in Abu Dhabi wouldn't be quite this extreme. This would be somewhere located more in North America, probably in Alberta. So, okay, as you can see, the path of the sun during the summer is higher and longer than during the winter. So this is the summer sun, and then this is the winter. So I could even, actually I don't really want to draw it. I think you guys kind of get that. So the longer the path, that is why we have longer hours of sunlight in the summer. So if I was to even count this, like 1, 2, oops, that's not what I wanted to do. Sorry. Like, see how long this would take? Like, if we're doing this, like, this would be like a ratio. 1, 2, 3, 4, 5, 6, 7. Like, if that's kind of like the path that it takes, okay, 7 seconds, maybe that was like 7 hours. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so that kind of shows that there's just a difference. And of course, when we have the sun up for longer, then it's going to allow more time for the earth to heat up, which also relates to why the temperatures are warmer. Also, as we learned yesterday, the rays of the sun are more direct. Remember that experiment they showed you when the flashlight's beaming? This one, the rays are more spread out. This one, the rays are going to be much more intense when they're directly over top at noon. This point represents noon, where it's the highest in the sky. We'll be learning a bit more about that later too. Okay, so the next thing is, okay, this is kind of cool. So the sun's angle throughout the year. Okay, so this red line is showing the sun's path in June. So notice that it is the highest, June 21st is the highest that it would possibly reach. And then the equinox is when there is equal day and equal night. So that's the blue path in the middle. And then the sun's path in December, on December 21st, which is winter solstice, then that is the shortest. Now here's something that's really cool. Okay, so the angle of the sun changes throughout the year because the tilt is 23.5 degrees. That is super important. Why do we have seasons? Because the earth is tilted. Now get this. In the northern hemisphere, the sun will reach its highest point on June 21st. Okay, that's the red line. Summer solstice is what it's called. And then in the northern hemisphere, the sun reaches its lowest point on December 21st, which is called the winter solstice. Okay, on March 20th or 21st. Oh, okay, this is actually more exact. March 20th and December 23rd, the sun will be at the same height. You could even search that. Most of the time we say it's March 21st, September 21st. If you say that like on a test or whatever, you're not going to be wrong, but this is technically more accurate. Which are called the equinoxes. And the root word of equinox means equal. So that means there's like the most equal balance of day to night that we would get wherever you're located on the world within the calendar year. Okay, next thing. This is where it gets kind of cool. Ready to have your mind really blowing? Okay, if the height, this is not grade 6 up, this is more than grade 6 up, but I think it's cool. Okay, if the highest point of the red line is 73 degrees, okay, so if we were to have a protractor and we measured it, right, say I did like my arm going up like this, then like this is what I'm measuring, or even, if I'm doing it across the bottom like this and I measure 73 degrees, okay, then the blue line would be 49 degrees. So we could do that. If I was to draw a line on here with our math skills, we could measure that as being 49.5 degrees, which looks about right. Okay, get this. What is 73 minus something to give 49.5? Huh, math geniuses. Guess what? 23.5 degrees. Huh. And is that ringing a bell so far? The highest point of the green line is 23.5 degrees. And then, so that is less the blue line. So here it is, look at this. So the blue line is, right, okay, so 49.5 degrees, right? That's the blue line. And then minus the green line, which is 23.5 degrees, we get 26 degrees, which would be the blue line. No, sorry. The red line is 73. The blue line is 49. And that means the green line is 23. Yeah, that's right. Those are the three lines. Okay, so 23.5 degrees. Can you believe that? 23.5 degrees. What do we know about 25.3 degrees? I hope you're saying it out loud. What do we know about that? Boom! I hope your mind is blowing. So cool. Whoever figured that out, kind of a genius. Okay, I had to share it with you. Okay, so now this is the last part of today, is you're going to flip to your Bill Nye the Science Guy Seasons page in your notebook, and then you're going to fill that out and then take a picture of it. Actually, I'm going to think about how I want you to submit this. Yeah, I'll probably have you take a picture of it being done and then uploading it onto Seesaw tomorrow by 1 o'clock. Hopefully that makes sense for you. If you do not have your COIL book, let me know in a private message and I can send you the Word document via Edmodo if you would like that. Okay, so that's it for today. All that you need to do is, I guess, 2 things. Number 1 is you have to go back and possibly make some edits, okay, to this guy, making sure that you are really happy with what you have written. And then maybe even based upon the Bill Nye video, I might give you a little bit more insight. Make sure that you have done both pages. And then you're going to fill out the Bill Nye the Science Guy page in your Science COIL notebook. Okay, have fun. Let me know if you have questions.